Hi guys, welcome back to new episode of HTTP connection series. Yes.
Yes.
Previous session, we have faced with a problem.
Yes.
We wanted to prove something, but unfortunately, we have faced with a simple problem. This session, we are going to show what was the problem and going to solve it.
Yes.
So let's go.
Of course. So last session, as Omid said, we were trying to use the Postman as another HTTP client against our HTTP server, and we faced the problem that it wasn't connecting. There were no responses. And now I'm running the admin again. It is running an HTTP server on the background, and I'm trying to connect to the loopback address and the port 12345, and I'm trying to get product list. And when I try to connect, we have this error here telling us malformed request. It is saying malformed response, sorry. Parse error, expected HTTP /. So last session, I just digged off the camera. I just saw that we are actually in the admin here, not in the server, sorry, in the HTTP server. When we are trying to send back the response, we are trying to actually follow the HTTP protocol. So the first line of the response in the HTTP protocol was the status line. And the status line was composed of 3 sections. The first part was the HTTP version, and then a space, and then the status code, then another space, and then the description of the status code, or reason phrase, they say a reason phrase. For example, the description of 200 is okay, or the description of 404 is not found. So the part here so we are actually trying to respond as an HTTP server. So our responses should comply to the HTTP protocol. But if we go to the HTTP protocol, we'll see that the HTTP version is all uppercase. And this here is telling us that I'm expecting HTTP / at the beginning, and I'm not seeing that. It's because that we are giving it in lowercase. If we give it in uppercase, HTTP / 1.1 is the HTTP version. And if you go to that protocol file, you'll see a section describing this HTTP version and how HTTP version is composed. For example, it's composed of uppercase HTTP and a /, and the version composed of 2 numbers, major number and minor number. And now if we run it again, and try to connect once more, we'll see that it is connecting and it's receiving the data. Yes, it is receiving data. It is receiving the headers. Our response has only one header, content length 56. And this is the one that we've passed. We can send other headers, for example, from our own, and also the headers that maybe the one that is writing the router decides to put. So this is another HTTP client here, and it is actually expecting to receive standard HTTP responses. And maybe some other HTTP client maybe fail parsing this part because we have put a dash as the reason phrase, and we should have some function that, for example, say if it is okay, 200, I'm sending okay, for example. Maybe another HTTP client, the Chrome itself was taking easy on us. It's some kind of a relaxed HTTP client, you know. It is taking easy. It is actually also testing other forms, for example, lowercase version of it is also trying to correct our mistakes, the mistakes of the server. But this one, the Postman, is strictly actually tries to inform the server, and it is not working. It wasn't working actually. So this is the first thing that we wanted to show you, and now we can move to, actually this is the part that we've not touched yet, the connector, and we want to convert it to HTTP connector. This is the one that we use as HTTP client. the HTTP connector. So I renamed this class. And HTTP connector, as we expect, actually has a function send. It receives a HTTP request, tries to connect to the server based on the information in the request, and then tries to wrap the response in an HTTP response. So we don't have the host yet in the HTTP request here, and we should also have it. We should have val host string, and host is actually defined in another, as I said before, is defined in another RFC, and I think it's URL RFC, and you can go and read that as well to see that all these URLs that we are using here every day, to see what are the parts, for example, it has a schema, the first part is the protocol, for example, the HTTPS here is the protocol, then comes a colon, 2 slashes, then comes the host until the next slash. And the host consists of 2 parts. The first part is the address, maybe a fully qualified name or an IP address. Here we just gave an IP address. Here we are using, for example, this tools.ietf.org is a fully qualified name that will be converted to IP address through one of the DNS servers that my system is connecting to. And then comes a colon and the port. But if we don't give the port, the browser always concatenates this :80, because if the protocol is HTTP, if the protocol is HTTPS, the port is I think 433. I've forgotten the default port. Each of these default protocols has a default port defined in their RFC. You can see that they are suggesting that please always use this port when you are writing a HTTP server, when you are going to deploy an HTTP server in somewhere. But we can actually override that. We can use another port, like 1, 2, 3, 4, 5 as HTTP server that we are using now. So that's another part. Then we have to actually put at least a slash. Then comes the resource URL, the resource that we are trying to locate on that machine, on that host. So we give the address of the host, this machine and this port, this process that is using this port. And then we are actually trying to tell that process, which is using that port on that machine, to, for example, delete this resource or give me this resource. So this resource, by this is the second part or third part of the URL. For example, you are saying A, B inside A or C, and it has to be at least a slash. And if you, again, don't give a slash, the browser will put the slash for you. And because browsers nowadays have always put these colon default ports and the slashes for you, and also this protocol at the beginning, most of the users are not aware of these things, being handled for them on their behalf. And if I want to prove that, we can show you that actually we have to run the test HTTP server to print the message. We had this test HTTP server, and let me just print it. Let me just print what we receive here. Print ln the message so far. Let me close this one because 2 processes cannot take the same port at the same time. 1, 2, 3, 4, 5. Let me run this one. So we've changed the HTTP request, and that's because the host has been added. The host is 127.0.0.1 and port 123.4.5. This portion is the host, not just the IP address. You should also give the port and also this here. We may have HTTP request. Okay, it's no, we have. Let's just make it run. Make it compile. And it's running. And now I'm trying to connect to that. I want to show you that. Let's connect it to local host on port 12345. And here I have to give this 12345 because we are using the HTTP protocol and we are not able to listen on port 80. If we could run the server on port 80, I could prove you that this browser is connecting on port 80 if we don't give the port. But let's just see what's happening here. So here you can see that if we see this is the HTTP request, and HTTP request, the first line is the I've forgotten the name of the first line of HTTP request, and at the first line it is composed again of three portions, three parts. The first one is the method, then space. The second part is the resource that the client is trying to reach, is trying to, for example, is asking for. Now it is asking for just a slash, then a space, then the HTTP version. So you can see we didn't give this slash here. There is no slash, but this browser is actually sending a slash. There must be something as a resource URL, and it is putting this slash here for us. If we don't give it, most of the time we don't give it. Actually, we are not aware that we have to. And for example, if I say A, B, C, and give some query string like name equals mass OD, and let me run the server again because we have not put it in. Okay, I run it again, and here again you can see that we have get space, and this is the resource. So the resource is the part comes after the host, and it has to be at least and a slash. A slash means the root, the index. Most of the time the servers map this slash to their index page or to their root page that they have, and they redirected that. Okay, this was another thing that I wanted to show you. So everything that we are using actually here, because it's on top of TCP network layer and UDP and TCP. It has actually an RFC file like this. RFC, they stand for request for comment, I think. They are these documents, these are standard documents governed by, I think, I've forgotten this is, for example, this has been written by the University of Minnesota, the URL, and it's been accepted globally. Everybody's using this, following this pattern, is using this since, for example, December. This is maybe the last update, December 1994. Yes, Network Working Group, NWG. Okay, now let's actually use another HTTP client. Before refactoring this, let's actually use another HTTP client that every programmer, every Java programmer, Kotlin programmer uses. Actually, if you want to connect through HTTP to some server, we don't use sockets for that, because we have to do everything actually manually. We have to construct the first line, for example, we have to follow the HTTP RFC line by line and correctly. And we are trying to write an HTTP client here ourselves that is using the sockets. But before that, let's use the standard way in the Java that every programmer uses. But also programmers tend to use other libraries on top of HTTP URL connection that we are going to use here. For example, I know that Android developers nowadays are using retrofit or volley, and they are on top of this thing that we are going to use now, and this is on top of socket. So we can use the socket as the first line, as the first layer, and connect and manipulate it actually ourselves to see what is happening. Then we can after we see, okay, what is HTTP request, what is HTTP response, and what is going on, and we have a good knowledge and understanding of that, we actually abstract it and come to another level, like this one that we are using, we are trying to write, or the one that the Java JDK has itself. And after that, for example, others are using other libraries on top of that, like retrofit. And we will see those as well. So now let's run this HTTP server again, our HTTP server, the admin application. And this is test HTTP server. Let's create another file for test HTTP URL connection file. I'm making it a file, creating a main function. So if you are a Java programmer or programming the languages that are JVM languages like Kotlin, you have access to JDK. And if you want to make an HTTP connection with the JDK, you have this option. You can actually first, this URL class is inside java.net package that is inside JDK. First, you have to create an URL. So the URL here is HTTP. You have to give it the whole URL this time because this is not the Chrome or anything that will correct things for you on your behalf. So we can actually connect to some FTP server with FTP protocol or other protocols. This URL RFC is actually for all the protocols. The first part actually says that comes the protocol, for example, HTTP, HTTPS, FTP, other. We have thousands of protocols. You can write actually we wrote our own protocol. We could put a name on that and write an RFC comment and then actually send it to these guys here and ask them to publish it. And if it is hopefully widely used, then we can actually get some credit on that. So first comes the protocol, then the colon // and then the host. The host is consisting of two parts.
Domain.
Yes, the host, domain and the port. The machine IP address and the port. Let's give it the local host or the 127.0.0.1 and then the port 123.4.5. Then, for example, let's ask for get product list. This is a URL. And now if I want to open a connection, it has open connection. This has a function on the URL, open connection. But the open connection returns URL connection. So because we know that this is an HTTP that we gave to this URL, and we know that the URL connection, we have an HTTP URL connection. Let me show you that. URL connection. I'm trying to go to the source code just to show you what classes are. We have file URL connection, FTP URL connection, HTTP URL connection, HTTPS URL connection. Actually, the JDK has implemented all these for us, and it will try to, based on the URL and the protocol that we are giving it, it will return one of these. But it will return it as URL connection here, URL connection, and we have to cast it as HTTP URL connection because we know it is an HTTP URL connection, this connection, based on this protocol. Val HTTP connection. Now that we have an HTTP connection, we have pretty much standard things of the HTTP client. So for an HTTP client, you can give headers, you can give the, query strings, or you can connect, you can disconnect. So these, for example, header field. Header fields are the headers. If we want to give a header, we can say set request. Here the headers are request property. Actually, if you give something here, for example, A is B, I'm sending header along the request. And also, for example, then after the connection, after we connect, we have an input stream and output stream. Yes. So the input stream, from the input stream, we can read everything and then print it to see what is actually returning. And then after the connection, we can ask for the headers of the response. Let me see the response code. Yes. After the connection has been made, we have a response code. The response message is that it was description phrase, something like that. So let's connect and actually print what is in the input stream. Let's write a while loop. Actually, we have to change our strategy for reading the streams. This is not okay, but just for the moment. Next byte input stream, let's bring it outside. Next byte dot read, and then we can say print next byte dot to char. Now let's run it. It will connect to our server, which is running the admin application. Okay, let me disconnect it and show you the first bytes. Let's see. Let's say if next byte is -1, indicating the end of the stream, break. Okay. You can see that we are capable of receiving the response, and then we are printing. So we are actually connecting to somewhere, to our own server. We are sending, for example, let me run the test HTTP server because I want to show you all the headers that I'm responding. So the server is running. Let's connect with this HTTP URL connection again. We receive this static HTML, and in the server we can see that I sent this header. It is actually sending other headers itself. I didn't send this host or accept or connection keep alive, user agent Java 15. I didn't send any of those, and I had to. If you read the HTTP RFC, you will see that if you are trying to write an HTTP client yourself, you have to include some standard request headers. For example, you should say the host that you yourself trying to the host that you are trying to connect, or you should say, for example, as a client, what are the things that you accept, the mean types as the response. You are, for example, this one is telling that I accept text HTML, image, GIF, and other things, and it is telling the connection keep alive. It is telling that all of these has meaning, and we can send our own headers. So we can send our data to the server through headers, through the resource URL, or through the body here. We could send with the HTTP connection. Before asking for the response, we could say, I'm trying to, let me, for example, HTTP connection, output stream, write. We could write something to the other side. And it will take care of all the headers and everything for us. It is putting this get for, let me show you, HTTP connection dot request method. We can say that request method, I want it to be post. And let's put another header like name mass od or let's, after the connection has been made, let's see what is the response code. Response code is HTTP connection dot response code. Let's see what is the response message or reason phrase. It was reason phrase. Let's connect again. HTTP server, HTTP client, and okay, the response code is 200. The response message is okay. This is the response body. In the test server, in the server part, you can see that it is sending our headers along with other headers. And yes, if you want to connect to some server, to HTTP server, most of the times you are dealing with this class, with these two lines of code. You create a URL, and then you open a connection and cast it to HttpUrlConnection. And then you can give your headers, you can actually assign and specify the request method. Then if it is a post and you want to send, for example, a JSON to the server, for example, say we will try to create product from remotely. Remotely, we will try to create a product. Then we have to send the properties of the product, for example, name, price, everything inside the JSON. Then we will try to connect to some endpoint on our server, and for example, products endpoint. Then we will give the request method as post, and we have to send some message, body, the product itself. Then the server will receive this message, try to actually we were trying to do that before here with the orders. We were sending, so the customer here is sending his order, his or her order, as JSON in the body. Okay. Most of the time, I myself use these lines just if I want to create an HTTP connection in Java. But others, because if you do a lot of HTTP connection in your day-to-day job, it will be a lot of boilerplate code. Then it is best to actually use other libraries on top of this. This is on top of socket. This is actually manipulating socket. And you can use other libraries on top of this that will receive callbacks, for example, for when actually the response is ready or the request had error or something like that. If you do it manually, you have to have a lot of try catches and manipulation to see, okay, this error, we had this error. But if you use other libraries like retrofit, actually with retrofit, you can create an interface. You can give the description of your requests, and it will generate the body of the connection for you. For example, you can say, I want you to connect to this endpoint. Do a post, send these headers, send this, for example, and you can define this with an annotation in retrofit, and it will generate. It's not doing magic. Actually, we can write the retrofit ourselves to prove that this is the thing that we are trying to do here. We are trying to tell you that everything is a written program. We can write it ourselves. We should not see at things like they are doing magic. Okay, now our own HTTP client, like this HTTP URL connection of the JDK. We are trying to write our own HTTP client. So this request, we just added the host, yes? And so each request will have a host, a method, request method, a request URI, headers, and the body. That's, I think, pretty much everything. And also the protocol, but because we know that it's an HTTP request, we don't want to receive that. So the connector will try to create a socket, the host and the port. So after receiving the request in the host, let's receive the port actually. Val port as integer. Okay, the host and then the request dot port. Then it creates a socket connection. It gets the input and output stream, and then it sends the method of the request. Serialized request of method / body. This is not correct. We have to request. I've forgotten the standard name for that. Let's see, it was HttpUrlC 2616, document 2616. And on the section 5, request line, yes. The first line is the request line. Request line has a method space request URI space HTTP version, then a CRLF. So our HTTP client request line, yes, it was request line. Again for yes, request line has this request dot method, then space, then the request URI, of course, request URI, then space, then HTTP /1.1, then CRLF, which is \r\n. So this is the first line of a standard HTTP client. Then we have to write the rest of the headers, all the headers, delimited by an CRLF if there are more than one. It's like this. We have to say, let's say val request itself is an empty string at the beginning, request string. Then request string, we concatenate the request line. Yes, it should be a var, not val. Then for each request dot headers, for each of them, for each, actually it's a map, and we are doing a for each on that. It will give a map entry. There are alternative for each the variations. For example, will give key value pairs for us, but we can use this. So then we have to add to the request string headers. So each header, it consists of key value pair, key, then a colon, then a value. And we can see that here, the header, we have the header sections somewhere defining the, these are the standard headers that you can go and read what does an accept means and other things. So first comes the it dot key, then a colon, then it dot value, and after each header comes an CRLF \r\n, and after all the headers, as an indication of the end of the headers, we again put another CRLF stated here. Let me show you. Okay, this is the ending CRLF. We will always have two consecutive CRLFs at the end, indicating the end of the message and the beginning of the message body. And then comes the message body. And because we are writing the client ourselves, we have to check to see if our request, the request that has been sent to us, if it has a body. So we use this host, we use this method, we use request URI, headers, and port. This is the body. If we have body, then we have to include the content length header, because we are writing the HTTP client. And actually this URLConnection is doing all that on our behalf, and we are not aware of that. It's doing everything. If we don't do that, for example, Postman won't work. The Chrome won't stop. It will just spin forever. So the HTTP connector, we have to say if request dot body is not empty, then first let's add request to the request string let's add another header, content length, colon, then comes the value. For value, let's calculate the amount of the body in bytes. Actually, as the message body here, you can send, we are sending a sequence of bytes, not a string. There is nothing as a string when you are sending and deserializing the stuff. You have to put another header as the content encoding to indicate that these sequence of bytes means a UTF-8 string. These sequence of bytes means a JPEG picture. These sequence of bytes, for example, I don't know, means an JSON, which is in ASCII encoding. So we are deserializing it. Request.body.length, because we know that the characters that we are using in the strings here actually are in the ASCII, and each of them maps to a single byte. It's safe to use this length. But if we want to write a fully fledged, a complete HTTP client, we have to both have bodies of other than string. We are now just accepting string bodies. We have to accept other types of body, like a byte of array or an input string. Okay, let's put this after. Let's put this after that, because we have to put it after all the headers. We might have one here. Then comes CRLF, then ending CRLF, and then the body. So we append to this request string the body, request.body. Then we have this request string. All we have to do is we have to serialize this string. So there is a function, we've used it a lot, to byte array, and when we are serializing, we have to give the char set or the encoding. For example, if I say this string that I'm giving you is in the char set of UTF-8, and please deserialize it, it will, for example, take 2 or 3 sometimes consecutive bytes, or it will take and try to map it to a character. But if I say ASCII, it will take 1 byte at a time, you know. And if we don't give anything, the default value, we've not used the functions with default values in the Kotlin yet, but the default value is charsets.utf8. This is the default value, charsets. You can see other encodings here, UTF-16, UTF-32, US ASCII. So we serialize the string that we created out of this request, HTTP request, and we are trying to send it as a sequence of bytes to the other side. Then we receive the response. In the response part here, if we again get back to this here, the response section is the 6, has a status line, and the status line is HTTP version space status code space reason phrase. So first we try to read until 2 consecutive CRLFs. Let's read that message so far. Read to char. Message so far. We concatenate the received byte to character. Get rid of all these. And if we see if message so far ends with 2 consecutive CRLFs, then we break. Now the first line of this message so far is the status line, and the status line, we have the status code. Yes, we have here, we have the status code. We don't need this reason phrase actually. So let's say message so far dot substring before first backslash, before first CRLF. This is the first line, yes? In the first line, after the first space, substring after the first space, yes, then substring before the first space. This will be the status code.
Okay.
First, actually, I'm chaining all these. We can
Yes.
first on the message so far, we substring before the \rn. Then
after
on the
that,
result of that, we substring after the first space.
then before the first.
Yes, this will be val status code, and we can let's leave it as a string. Then another thing that we are interested in are the headers. After the first CRLF comes the headers until the last, until here. So we say message so far dot substring after first again CRLF until the before the last, let's say last CRLF. These will be the headers splitted by, delimitered by CRLFs themselves. I can say again, dot split them with \r/n. These will be again headers string. So this is the status code, this is the headers string, then nothing, then comes the message body. Okay, so also let's see, status.toInt, we are sending back empty map. We should actually send back headers map. If we want to convert this headers string, which is a list of a string, to a map, we did this before, I remember. We have to say headers string dot first map it dot substring before colon. We created a pair, we remember that. It dot substring after the colon, and then with a list of pairs we can call a function and tell it to create a map. So val headers map. So now we have the headers map, we can send it back. And then the body will be the rest of the stream until the end, and we as an HTTP client first have to see if in the headers map we have content length, and let's say content length, if the headers that we are receiving from some server that we have connected has content length. If it doesn't have content length, we will ignore the body. Because we are following this protocol, and based on this protocol, we are expecting the server to be a standard server and include any content length if it is sending us message. So if it has, then we say headers map dot get. Actually, we can use this as get content dash length, and we know that we have it. Then because it will return a nullable value. I dereferenced the null and I try to convert it to integer. Val content length. Then we read as much as this content length from the stream, and we say we have this input stream, yes, in stream dot read n bytes as much as content length, and this will return a byte array. And now I'm trying to convert this byte array to deserialize it to string. So I can say to string, and I can give a char set and tell it that these bytes, for example, you have to go to UTF-8 char, because the client that I'm working with, I know that he has serialized in the UTF-8 char set. Char sets dot UTF-8, and this will be the body. Okay. And the status code. Status code. Okay, I think this should work. In the HTTP server. Notify me actually we are HTTP. We are creating HTTP request here. Why? Why is that? HTTP request callback content length. The connector. Where is the connector? Oh. We are doing everything here ourselves in the server. So we accept, we get the input stream and output stream, and then we get the request line and everything, the body. Then we create the request. Yes, we create the request and give it to the callback. Let's put some, actually, we have to check the host in the headers that is coming from the client and put them here, actually the actual ones, but just let's use it at the moment. So this is the server. Let's run it. Oh, no, I just run this admin application. Let's run the admin application. We have an error here. Let's give the port separately as an integer number. 1, 2, 3, 4, 5. The admin is running. Let's run the customer application here, which is using the HTTP connector that we just refactored. And if we ask for product list, we have number format exception in the receive response because the status code is not okay. Let's see. Let's run the customer as debug again. Ask for product list. We are here and we are receiving the status code. Okay, the message so far is okay. It's HTTP/1.1. Then 404. We are missing something here actually. No, we are missing nothing. So the first part, if I want to prove that what will happen for the first part, message so far, if we substring, let me just give some space here, substring before /r/n will be HTTP, will be the first line. So the first part is okay. Then we set substring after the first space will be 404. This part is okay as well. Then we set dot substring before the space, and it's 404. And this should be okay, but it's empty. Substring before. Let me copy and paste it. Because this should be in space. This should be in space. Let me run it again. The customer 1, and the response was 404. Why? Let's see why. The customer application. Actually, it's
working.
Yes, it's working. It's the admin is responding with 404. It's saying that we don't have that resource that you are trying to reach. So we are giving get product list to the HTTP request. Oh, we have to as an HTTP client in the HTTP connector, we have to append a slash at the beginning of our request URI if the user of this API is not giving that. Because based on the URL RFC, each URL in the request URI part begins with a slash. So if we say before sending here in the request URI, we have to say val request URI equals if, again I'm using if and expression, if request URI starts with a backslash, and slash, sorry, then the request URI itself, but else append and slash to the beginning of request URI. I appended and slash, and I use this here. Now, if I run the customer again, and I send it again, 404 starts with, if it doesn't start, so in the admin side, if we receive slash product list, let's see what are we receiving in the admin side. We are receiving get product list, the method get product list. So this is the println that we are using, yes? And you run the admin again. Then the customer. Then let's send one. Let's go to admin. Okay, we are receiving get product list without a slash. And oh, the method. The method is, we have some mistake in our connector because we are sending, or maybe in the HTTP server, let's see. First, in the request line comes the method, then a space, then a request URI. We have some mistake somewhere. And I think our time is almost over. We can debug it in the next session. We have an error in the HTTP server or in the HTTP client. And you can see, actually, I just wanted to prove you that this 2 lines of code, this class here that is inside the JDK is doing everything that we are writing here. And this is not actually complete. We might write, for example, this is 100 lines of code. We might write, for example, 2,000 lines of code to create a complete HTTP client that we can ship it to everyone and expect them to use for everything. And we don't want to do that always, but first we want to see these things ourselves, manipulate them, and then we will use other actually abstractions over them, like this HTTP URL connection that is inside the JDK. Next session, we will debug this and we will continue. Any question?
No, nothing. Thank you very much.
Thank you.
Thank you, guys.
And bye.
Bye-bye.